Hello everyone. Last class we are discussing about the basic terminology using in the network theory. Today we are going to discuss about two major types of sources which are used in the different networks and three important components. Those are, first of all, we are going to explain sources. Sources means here DC and AC. DC is a direct current, AC is a alternating current source. DC direct current means here the symbol is like a battery. In this in this in this source, electrons are the negatively charged carriers. Those are attracted towards the positive terminal. So the electron movement is from negative to positive, and the electric field is from positive terminal to negative terminal, and the current flow is opposite to the electron movement because here current I is equal to dq by dt. According to this formula, here the charge of an electron is a negative. So minus dq by dt. That's why the current movement is in opposite direction to the electron movement. Here the current amperes is known as coulomb per second. Suppose 1 ampere means it will indicate 1 coulomb of charge movement per 1 second. Here DC signal is as shown in this figure. Here voltage or current, it will does not change with time. But in case of AC supply, the current and electron movements are same, but the current or voltage is going to be changed with respect to time. Signal representation of AC supply is like this. Next, Next, we are going to learn about three important components that are mostly used in any of the electronic devices. The first one is a resistor. Now we are going to discuss about the resistor. Resistor is a component which exhibits the property of a resistance. What is a resistance means? The property of a material which opposes the flow of electrons is nothing but resistance. Opposing the flow of electrons means flow of electrons is nothing but current. Here resistor formula is R is equal to rho L by A, where L is the length of the material, A is the area of cross section of the resistor, and rho is the proportionality constant, which is depends upon the energy gap and temperature. Energy gap and temperature. This rho is depends upon the material property. So depends upon the material we are taking, the rho value will be varied. Suppose we are taking one of the conducting material here and connecting the voltage source V, and current I will be flowing through the conductor. Then the resistance formula is R is equal to V by I. if the resistance is 5 ohms, that means for 5 volts 5 volts applied voltage, we get 1 ampere current through this resistance. Suppose we are taking a carbon material. Form graphene is the best conducting material. We are considering here the energy bands. In any conductor, the energy bands are com- combined. Those are conduction band and valency band. That's why for small voltages only, there is a flow between the valency band and conduction band, electron movement between valency band and conduction band. For some of the material, for small voltages only, this flow will be happen, but for another materials, some large voltages, this flow will be happened. That is known as material property. That is depends upon the proportionality constant rho. Rho is known as resistivity or specific resistance of the material. The units of the rho is ohm meter. Here, another important note is resistor is a bilateral element. Bilateral means the current flow in two ways. Capacitor. Next one is capacitor. Capacitor is also a bilateral and unilateral element. Some of the capacitors like paper capacitors, mica, ceramic capacitors are bilateral. Unilateral are electrolytic capacitors. Symbols are also different. You can observe here. This having polarities positive and negative. There is no polarities. That's why two-way current flow is happening. Here capacitor structure is two conducting plates. In between them one dielectric material is there. The value of the capacitor Q is equal to CV, where C we can write it as C is equal to Q by V. That means for 1 farad capacitance it means 1 coulomb of charge storage per 1 volt. Another formula for capacitance is Vc is equal to 1 by C integral Ic dt, where I is the current flowing through the capacitance and Vc is the voltage applied to the capacitor, and energy stored in the capacitor E is equal to half CV square. From the energy also we can find out the voltage. The voltage and energy relation is V is equal to minus integral E dl, where L is the length between the two plates. Here we are discussing about the value of the capacitor. Capacitor value C is equal to epsilon A by D, where epsilon is epsilon naught and epsilon R. Epsilon value depends upon the dielectric material what we are using. Suppose area as a dielectric material, there is epsilon R is equals to 1. Epsilon naught value is 8.854 into 10 power minus 19 Faraday per meter. Here epsilon naught is absolute permittivity and epsilon R is a relative permittivity. Here what is permittivity? Permittivity is a ability of a material that stores the electric field without breakdown is known as permittivity. This permittivity depends upon the material, and here A is the area of the dielectric material and D is the distance between the two plates. If you, if you observe here, permittivity is a ability of material to store electric charge without breakdown. So it indicates the capacity of the dielectric material which are used in the capacitor. See, there is a absolute and relative permittivity. Relative permittivity is equals to permittivity of the material by permittivity of the free space. If we are taking air as the mm, air as a dielectric material, then the relative permittivity is equals to 1. Now let us see how the capacitor is going to charging and discharging. Here capacitor charging, connect the capacitor to the electric source, and there is a switch arrangement. Here positive terminal of the battery will attract the electrons in this plate. That's why the electrons are moved towards this positive terminal. So after leaving the electron, there is ion formation in this place, that is known as that is a positive ion formation in that plate. And after this, these electrons are moved towards the another plate of the capacitor. This plate becomes negative ions because extra electron is added in this. In this way, positive negative, there is a electric field formation between these two plates. It will happen very slowly. So the electric, after removing switch, the electric field is stored in the capacitor. This capacitor is simply acts like a say small battery. Coming to the discharging of the capacitor, in the discharging of the capacitor, there is positive and negative terminals. The electrons are moved from negative to positive terminal very slowly. In this way, discharging will happen. If you connect an LED bulb, that will be glow. So the capacitor charging and discharging creates this waveform. Here the voltage across the capacitor is Vc and time t. There is a charging and slowly discharging will be happen. Okay friends, thank you everyone. In the next video we will discuss about the value of, we will discuss about an inductor. Value of the absolute permittivity is 8.854 into 10 power 12 Faraday per meter. If you observe the charging of a capacitor, capacitor in this capacitor is charging by moving the electrons, by attracting the electrons towards the positive terminal. Electron movement is from east to is uh, here the current movement is opposite to the electron movement. That's why electron will move from positive to negative terminal. Current will flow from negative to positive terminal. That is known as IC. Main important thing is capacitor allows main important thing is capacitor does not allows the sudden changes in the voltages. It will charged slowly and discharged slowly, as shown in this figure. Does not allow the sudden changes in voltage. Thank you everyone. If you are understanding this, please like, share and subscribe. In the next class, we will meet with the topic inductor. Thank you once again.